Hi. Welcome to Mathematics of Information Technology. Mathematics of Information Technology is a course which offers an introduction with broad applicability to several areas of discrete mathematics. Computer logic, algorithm analysis, telecommunications, gambling, and public key cryptography are areas of application. In addition, it incorporates some basic concepts in statistics, computer science, and more mathematics studies that are useful. Discrete mathematics are the subjects covered: sets, relationships, logic, graphs, mathematical inference, and equations of difference, probability and permutations and combinations, protection and encryption of information, prime numbers, congruences. Introduction to Assignment 1. Topic 2. System of linear equations. Linear systems AMP, matrix. Systems of linear equations emerged in Europe with the introduction of coordinates in geometry by René Descartes in 1637. In fact, in this new geometry, now known as Cartesian geometry, linear equations represent lines and planes, and computing their intersections amounts to solving linear equation systems. Determinants were used in the first systematic techniques for solving linear systems, first considered by Leibniz in 1693. In 1750, Gabriel Cramer used them to have explicit linear system solutions, now known as the law of Cramer. Gauss later further defined the method of elimination, which was originally classified as a geodesy advancement. Hermann Grassmann published his theory of extensio in 1844, which contained new fundamental themes of what is now called linear algebra. In 1848, the word matrix, which is Latin for womb, was invented by James Joseph Sylvester. System of linear equations can naturally found in our real lives. Usually, when there are two unknowns or variables to be solved, the problem of system of linear equations come up. A system of linear equations, or linear system, in mathematics is a sequence of one or more linear equations that include the same set of variables. A linear equation in one unknown is an equation of the form x equal to b, where a and b are constants and x is an unknown that we wish to solve for. Similarly, a linear equation in n unknowns is an equation of the form the equation below, where a1, a2, and soon and b are constants. The name linear comes from the fact that such an equation in two unknowns or variables represents a straight line. A set of such equations is called a system of linear equation.
In this part we will be showing how to solve the system of linear equation. The system of linear equation can be solved using matrix by converting linear equations to augmented matrix form. So, let's try to solve this example. Step 1. Convert the linear equations to augmented matrix form. Then apply these three operations, which are multiply an equation through by a non-zero constant. Interchange two equations. Add a multiple of one equation to another. And using this sequences to achieve identity matrix. Step 2. Change value in column 1, row 1, to 1 by using value in each column of row 1 multiply by 1/2. Thus, you will get the value of column 1 equals 1, column 2 equals 0, column 3 equals 1, and 1/2 in column for solution. Then, update the value in the matrix. Step 3. Change value in column 1, row 2, to 0 by using value in each column of row 2 and row 1, then substitute in R1 multiply -3 plus R2. Thus, you will get the value of column 1 equals 0, column 2 equals -1, column 3 equals 1, and 11/2 in column for solution. Then, update the value in the matrix. Step 4. Change value in column 1, row 3, to 0 by using value in each column of row 3 and row 1, then substitute in R1 multiply -6 plus R3. Thus, you will get the value of column 1 equals 0, column 2 equals 1, column 3 equals -7 and -3 in column for solution. Then, update the value in the matrix. Step 5. Change value in column 2, row 2, to 1 by using value in each column of row 2 multiply by 1/-1. Thus, you will get the value of column 1 equals 0, column 2 equals 1, column 3 equals -1, and -11/2 in column for solution. Then, update the value in the matrix. Step 6. Change value in column 2, row 3, to 0 by using value in each column of row 2 and row 3, then substitute in R2 multiply -1 plus R3. Thus, you will get 0 for column 1 and 2, column 3 equals -6 and 5/2 in column for solution. Then, update the value in the matrix. Step 7. Change value in column 3, row 3, to 1 by using value in each column of row 3 multiply by 1/6. Thus, you will get 0 for column 1 and 2, column 3 equals 1, and -5/12 in column for solution. Then, update the value in the matrix. Step 8. Change value in column 3, row 2, to 0 by using value in each column of row 2 and row 3, then substitute in R3 multiply 1 plus R2. Thus, the value for column 1 and 3 equals 0, column 2 equals 1 and -71/12 in column for solution. Then, update the value in the matrix. Step 9. Change value in column 3, row 1, to 0 by using value in each column of row 1 and row 3, then substitute in R3 multiply -1 plus R1. You will get 1 for column 1, 0 for column 2 and 3, and 11/12 in column for solution. Then, update the value in the matrix. So, you have achieved identity matrix, and the value of x1 is 11/12, x2 is -71/12, and x3 is -5/12. The simple idea behind these operations is that you use the elementary row operations to convert the transformed matrix to reduce row echelon form or identity matrix. Hence, you could find the respective value of x1, x2 and x3 by using substitution method.
Introduction to Assignment 2. Topic 4 Basic Calculus. Function. A function is a binary relationship between two sets that compares every element of the first set to exactly one element of the second set. Typical examples are functions from integers to integers, or from the real numbers to real numbers. If the function is called f, this relation is denoted by y equals f, x, where the element x is the argument or input of the function, and y is the value of the function, the output, or the image of x by f. The symbol that is used for representing the input is the variable of the function, such as f is a function of the variable x. For example, when given the equation y equals x plus 2, y was defined as a function of x, it gives the rule add 2 to x. This rule assigns to each input x exactly one output x plus 2, which is y. So, if x equals 1, then y equals 3, if x equals -4, then y equals -2, the independent variable is x and the dependent variable is y. Usually, the letter F, G, H, capital G, capital H and so on are used to represent function rules. If y equals x plus 2 defines y as a function of x, then we say that f is the function of x, and we can write it as fx equals x plus 2. Fx, which is read f of x, means the output number in the range of f that corresponds to the input number x in the domain. Next, we will show how we can form the linear equation by just using 2 points of any coordinates. For instance, in this example of a line that passes through the 2 points -6, 1 and 1, 4. First, we need to find the slope between the two given coordinates by dividing vertical change to horizontal change of these said points as shown here. Next, substitute the value of the slope we found just now into the equation form as y equals to mx plus c, where m equals to slope. Finally, we need to find the y-intercept, which is c that was shown in the equation we formed just now. By substituting the value of y and x by any coordinates in the line, for this case, these two coordinates from this example. For now, we use the coordinate -6, 1. And now we have succeeded to form a linear equation by using two given coordinates. From this equation we formed, we can easily see what type of equation is this. For instance here, this equation is increasing because the slope is positive, and we can see where will the equation intersect in y-axis. Here, it will intersect at 25/7. And before we end this video, allow me to introduce everyone to my group members that are responsible for making this video today. who are Li Zongying, who is the group leader that is responsible for creating the scenes for topic 4 example and conclusion, Chen Hui Deng, who create the scene for topic 2 example, Wang Zhi Deng, who is tasked to produce the scene for introduction of topic 4, and lastly Wang Chi Ken, that is tasked to create the introduction of topic 2. Thanks for watching today.